1.9 systems of equations
In a lot.
in 3 variables. You've done systems of equations in 2. Substitution, elimination. You did that freshman year, you did that earlier this chapter. Now, we're going to do it in 3. 3 equations, 3 unknowns. They are very, very, very similar to equations in 2 equations, 2 unknowns. Obviously, the trick is you have an extra variable and an extra equation to mess with. Okay? That's the hard part. Like systems of equations in 2, systems in 3s can have one solution, infinite many solutions, or no solutions. Okay? All 3 are technically still in play when you get the right examples. For you guys, you will always have one solution. Okay? You will always have one solution. Now, an ordered triple is what these are going to be put in, which is brand new to you guys. It's a solution to a system in 3 variables. So how you had ordered pairs, they were x and y. Now you got ordered triples, x, y, z. So you're moving from talking about points in a 2-dimensional space to now talking about points in a 3-dimensional space. Okay? Your length like this, your height like this, and then your spacing this way. Make sense? Okay? Or I guess this way. I don't know which one. I missed one. This, this, this. That was 3, right? Yeah. Okay. There it is. Got it. Okay. Real world stuff, this is all bound. Okay? If you look through your book, it's like intersections of planes where they intersect, not airplanes, but like planes. You know what I'm talking about from geometry, those kinds of planes. Different kinds of stuff from that you can do. We're going to kind of do word problems with this. We'll hit that today/tomorrow, but not too hard. Okay, we're just going to hit the basic word problems. All right. Solve the system of equations, blah, blah, blah. Similar to solving in 2, use substitution, elimination. Here you can mix and match, okay, depending on what the situation presents you. And that's kind of why learning how to do substitution, elimination earlier on is so important, because now it is kind of a free-for-all. If the situation presents a substitution, you go with that. If it presents an elimination, which most of these will still present elimination to you, you roll with that. Okay, so it's kind of a choose your own battle, choose your own poison kind of deal. All right, questions on this? Stone, thank you. Everybody good?
I grabbed it. Go.
Okay, 3x minus 2y plus 4z equals 35.
We have to get it.
Quiet. Let me finish. Okay? I appreciate the enthusiasm.
I just thought when you paused, that was.
No.
When you was,
My pause is big on my coffee. I appreciate the enthusiasm.
I respect that.
Curve it down. Negative 4x plus y minus 5z equals negative 36. 5x minus 3y plus 3z equals 31. Okay. Here's your first one of these you've ever seen before, correct? Alright, so here's what your goal is. You want to do substitution or elimination in order to turn this system of 3 equations, 3 unknowns, into a system of 2 equations, 2 unknowns. Once you do that, you can turn that system of 2 equations, 2 unknowns into a problem like you did all the time. Substitution, elimination, whatever the case may be. Okay? So, that's where this starts to get messy. Okay? Organization with this kind of problem is paramount. Okay? And the reason I say that is because, not because I was organized in high school, is because I wasn't. I was all over the place. I had no system, bless you, as to where my flow of work was going. I was all over the page. I had lost myself in my problem. Okay? So I'm on that side of that fence. Some of you guys will be too. Okay? Yes, I said guys. Girls, you'll be mostly okay. You're pretty. Guys, good luck. Okay? Now, in order to do this, your best bet is to look for one of those 9 variables that have a coefficient of 1.
Found it.
Found it, right?
Why?
Did I put it smack in the middle?
Yeah, you did.
Like it's meant to be.
Yeah, it's why.
Okay?
Well, why? But why? But why? What? Who?
Guys. So, what you do, I'm going to number these. Alright? Or letter them, actually. Just so we don't have numbers and letter numbers. A, B, C. Okay? You're going to pick a pair of equations. Okay? You're going to pick a pair of equations. So I'm going to take A and B. Alright? But I'm not just going to take B. I'm going to take B and multiply it by a number so that when I add A and B together, it's going to get rid of my Y's. So that number is going to be what? 2. So I'm going to write this as A and 2B. And I'll put it right there. Okay? The nice part, A just gets to come along as it is. 3x minus 2y plus 4z equals 35. B, you double everything. So negative 8x plus 2y. Whoops. There we go. Minus 10z, elimination. Equals negative 36 times 2 gives you negative 72. Add those up. Like you would. Like elimination, but just with 3 now instead of just 2. Alright, so 3x minus 8x gives you negative 5x. Negative 2y plus 2y gives you 0 y's. Okay? 4z minus 10z, negative 6z. And 35 minus 72. Should be negative 37, right? I was trying to do it in my head real quick. Okay? Now, highlighter type people, this will really come in handy. Okay? Either highlight this guy, put a star next to it in a highlighter, have a pen ready, highlight that guy. You need to know where that guy is at all times. Okay? Yeah, there you go. Yeah. Yeah. Okay. Everybody good with that? Yes? No?
Yeah.
Okay. Now, we've done A and 2B. Okay? Your next step, once you do that, you pick another pair of equations.
Alright, B and CC.
Do the exact same thing, eliminating the exact same variable. Except you cannot pick A and B, because you already did. Okay? So you got to pick something else. So you can't do A and B. You can do A and C, you can do B and C. Okay?
B and C.
Well, I would do B and C, the same reason why I did A and B.
They got the 1.
Y's got the 1, B's got the 1 Y in it. Okay?
That's the most valuable asset.
It is. Okay? So now you're going to do C and 3B. Okay, so C is going to stay the same. 5x minus 3y plus 3z equals 31. And then triple everything in B. So negative 12x plus 3y minus 15z equals, hold on, 9, negative 108. Is that right? 6, 12, 18? Yeah. And then you add those up. So negative 7x, 3y's are gone, minus 12z equals what? Negative 77? Okay. Start that one. If the first one was Odell, that one's Brandon Marshall. Yeah, I know. Okay, but hey, but you guys stay on the same team. You guys started the reference,
I'd rather go Sterling Shepard over Brandon Marshall.
So I just went there. All right. Okay.
Brandon Marshall.
Save it. Okay. Makes sense. Now those two stars are now what you're going to take and create your system of two equations with. Okay. Yes.
Why do you do 2b and 3b again? Like why do you?
Okay. So you do A and C here and here. The reason you do 2b is because Y's got by itself, right? So you double Y, it eliminates with A up here.
You just have to get Y to do it so it cancels.
Right.
Oh, like elimination?
Right, exactly like elimination except with 3 now. Okay? And it doesn't always have to be Y. Okay? Whatever variable's by itself is what should dictate where you go with your problem. Okay? Now you take your two start equations, which I'm going to put over here in blue since I started them in blue. I need to look over here to see what they are. So negative 5x minus 6z equals negative 37. Negative 7x minus 12z equals negative 77. And now you do normal substitution elimination on that guy. Okay? So we're going to multiply the top one by? A little better. Negative 2. Alright. Which from there is 10x plus 12z. Or, yeah, okay. Sorry. Equals 74. Is that right? Now add those up. You're left with 3x equals negative 3. Divide by 3. X equals negative 1. Okay? Everybody good? Okay. It's not done. You still got to find B and, or Y and Z yet. Okay? Hang on. Madison. When you take your two start equations, or right here, see? I coupled them up as a system of 2, right here. I doubled the top one by a negative 2, so that way my z's fell out. Add them all up, solve for x. Okay? Alright, ideas, what's next? Galloway.
Can't you just plug the x into the equation that only has 2 of them?
Which would be your two? Your two what?
Your 2 new ones?
Yeah, 2 stars.
Yeah.
Okay.
Can't you just do that?
That's
and
exactly.
then find Z, and
That's
then you just plug them both into the
That's
big
exactly it.
one?
Okay. Now you start. Here's what he's saying. Now you start working backwards. Once you have one variable solved for, you go back to one of your two start equations, because now you can substitute negative 1 in for one of these x's,
Yeah.
and then go solve for the z.
Oh, okay.
Once you've done that, you can take both those numbers back into your originals and solve for the last one, whatever the case may be. Okay, Nestor.
So once you get 1, you can plug it back into an equation of 2.
Correct.
Doesn't matter if one.
Correct. Does not. Correct. Then once you get the 1, then you start working your way back through your problem again. You go back to 1 with 2, and once you have those 2, you go back to the 3s. Okay? So, as you can see, the work to these is everywhere. Okay? So it's very important to... I like... My teacher just like threw it all up there, and you had to decipher it and everything. Okay? He was a crazy guy. You think I'm crazy? You ain't met him yet. All right?
Yet?
Not yet. But probably never will. I don't know. He does go to church around here somewhere, so you might. But he's a Bellow guy. Okay. But
Is his name Philip?
nope. So here's what I'm going to do real quick, just to give myself some space. I'm going to shrink down some of this stuff.
Oh, that's cheap.
I know, but I only got a screen to work with. You got a whole paper.
I knew you'd be able to do that. That's bad. Yeah. I'm just going to make this a little smaller. Might as well make it thin. I got C.
Okay. So now I'm going to take negative 1. I'm going to go into my first start equation, so negative 5 times negative 1 minus 6z equals negative 37, which means 5 minus 6z equals negative 37. Subtract that 5 over. Divide by negative 6.
Z equals negative 7.
Z equals positive 7. Okay.
Flip the equal signs over.
Now that you have that, you take 1, or negative 1 rather, sorry, and 7 into one of these three originals. Which one? Which one? Doesn't matter. Okay? Doesn't matter.
Mr. Mormon.
Yes, sir.
Couldn't you just put it in the new one?
You're 2-starred.
Yeah, my 2 side.
Well, you don't have a y in your 2 stars anymore. See that? And the last one you need to solve for is y.
We're solving for y.
Yeah, you got to get all 3. So since you have to go back to one that's got y's in it, so that'd be these 3.
Then we go back to Eli Manning and he just.
There you go. Right. Correct. As long as once you have these two, as long as you stay consistent. As long as you do, get rid of your y's first with these two, and then once you have these two, you take them over here and get rid of 1, and then once you have that one, you work your way back here to get your second one, and then you go back here. See, you can't take -1 back to your originals, because then you have -1 here, but you still have y's and z's, which does you no good.
So basically, all we're doing is figuring out x, y, z.
Yeah, that's it. Guys. Right. So you do AB the first time, you can't do AB again because you already did it. Okay? So, let's see, last time, I'm going to actually go, I'm going to go with B, why not? -4 times -1 plus y minus 5 times 7 equals -36, which means it's 4
plus y plus 35, or minus 35 equals 36. And you might as well subtract 4. Y equals 35. What? Oh, you gotta add like. Yeah, but what, no, it doesn't. That's so wrong. That's right. You have to add 30. Oh, never mind. Never mind. I was thinking we were at positive 36. Yeah, you're right.
Last step, as you do with order substitution, you write them in order pairs. These you write in order triples. X, Y, Z. All right? So -1, -5, 7. All right, let's do it. Let's see here. All right, let's take, quiet. Let's finish this up. Whoops. All right, let's go A, B, C. Let's go A and 2 and -5 C. All right. Okay, so A is 2x plus 4y minus 5z equals 18 times by -5 here, so 25x minus 15y plus a 5z, quiet guys, equals what, 85, is that right? Add them up, 27x minus 11y equals what, 103?
Yeah.
Oh, you did positive 5 instead of -5.
Yeah, that's how
You
I
gotta get it to eliminate. You did positive 5.
That's what I did too.
That's what you.
All right, let's go B and 2C, right? Yeah, so you got to pay attention to your signs, right? If they're the same, then you got to throw the negative into the 1.
Correct.
Okay?
-5 times -17 is positive.
So we go B
Oh,
and 2C. So B is -3 x plus 5y plus 2z. Shh, guys, hey, please. Minus 10x plus 6y minus 2z equals negative what, 34?
Yeah.
Add those up. Negative 13x plus 11y equals what, negative 61?
Yeah.
Okay. Take those two, put them together. 27x minus 11y equals 103. Negative 13x plus 11y, bless you, equals negative 61.
Oh, you
Get on your knees and thank the math gods if this ever actually happens to you. Okay? Because it's so nice. All right. So 27 minus 13.
Should we thank you, Mr. Mormon?
You might want to, yeah.
Thanks, man.
Actually,
Thank you, Mr. Mormon.
yeah. What's that equal? 42?
Father Mormon.
Oh, stop it. Stop. No.
He's out.
No.
What do you say? First warning. We can't say it. You get 2 strikes in this league, not 3.
No. All right, so now take that back to when your 2 start. I'm going to go to this bottom one, honestly. All right, so negative 13 times 3 plus 11y is negative 61, which makes this, what, negative 39 plus 11y is negative 61. Guys, add that 39 over, you get what, 22? Negative 22, is that right? So y equals negative 2. Take them together, go to C. I'm going to plug into C, but I'm going to do it like as I go, right? So 3 times negative 5 gives you negative 15. Plus 3 times negative 2 gives you negative 6. Minus Z equals negative 17. Which means, let's see here, negative 21 minus Z equals negative 17. Which means Z equals what, 4? Negative 4? Right on top of the logo. Boom, right over there. And then order triple them up, alright? 3, negative 2,
Do a negative 4.
negative 4.
What a cat.